Okay, for this section, we're going to start section 5.2. This is about the addition rule and the rule of complements. Okay, so the first thing that we're going to handle is a compound event. This is an event formed by the combining of two or more events. The main type that we're going to look at is the combining event or the compound event of A or B. Okay, and in A or B, it can be A happens, B happens, A and B both happen. Okay, and so the way that we do this in the general rule is it's the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. The example that I get is think of a high school campus, okay? And I talk about kids that are in athletics and kids that are in band. Now, at the particular high school that I teach at, kids are allowed to be in both. They're allowed to be on the football team and be in band, or they can play softball and be in band. So if I go to the athletic director and I say that, I ask, how many students do you have in athletics? And he tells me we have 400 students in athletics. And then I go to the band director and I say, how many kids are in band? He says, we have 200 kids in band. That doesn't mean that there's 600 kids in both activities, okay, or in the activities pulled together. Then I have to look at, say, Susie. Well, Susie plays softball and she plays the clarinet. So Susie got counted twice because the athletic director just counts Susie as a softball player. The band director just counts Susie as a clarinet player. Susie was in both. So Susie got double counted. So that's the reason for the subtraction is we've got to take out that time that Susie was double counted. Okay. Now, two events can be what are called mutually exclusive. And mutually exclusive is it's impossible for both to occur. So this would be, I am classified as a collegiate freshman. I'm classified as a collegiate sophomore. You cannot be a freshman and a sophomore at the same time. Okay. That distinction is made on the number of credit hours that you have. And so you either have enough or you don't. Okay. You cannot be both a freshman and a sophomore at the same time. So for example, a die is rolled. Event A is that the die comes up a 3. Event B is that the die comes up an even number. Okay, guys, 3 is not an even number. Therefore, event A and event B are mutually exclusive. Okay. A fair coin is tossed twice. Event A is that one of the tosses is heads. Event B is that one of the tosses is tails. This is not mutually exclusive because if I have the combination of one heads, one's tails, then I've actually met the requirement for both of these rules to occur. Okay. So in the event that they are mutually exclusive, because the probability of A and B is 0, you would not be subtracting anything off of that in line. And so therefore you could leave that part off. I personally generally tend to use just the general rule, and then I just subtract the 0 as I need to for this, okay? So we're going to take a look at a few examples here. Okay, so we've got, and they're going to give us the stuff. So if the probability of A is 0.49 and the probability of B is 0.5 and the probability of A and B is 0.46, down below my glare there. They want us to find the probability of A or B. Now, following our rule, that's the probability of A plus the probability of B minus the probability of A and B. So we're going to plug our values in. This is 0.49 plus 0.5 minus 0.46. Which is, let's see, it's going to be 0.99, 0.53 when it's all said and done. Okay. So the next one says if the probability of A is 0.7, the probability of B is 0.1, A and B are mutually exclusive. Okay. So now following our probability of A or B, again, I'm going to put up my general rule here. Okay, so this is going to be 0.7 plus 0.1. Because they're mutually exclusive, there is no overlap here, so it's going to be minus 0. That is going to be 0.8. Okay. And we'll look at one more. If the probability of A is 0.3, the probability of B is 0.4, the probability of A and B is 0.5. It asks, are they mutually exclusive? Guys, I can go and tell you right now, no, because that is defined, okay? The only way they're mutually exclusive is if that is 0. Now, I can prove it mathematically. This is 0.3, 0.4 minus 0.5. So that's 0.2. If they're mutually exclusive, then it should just be probability of A or B is equal to probability of A plus the probability of B, which when we do that math, that's 0.7. And these two are not the same. If they were mutually exclusive, then these two would be the same. But again, because they told me that the overlap has a probability of 0.5, then that means that they are not mutually exclusive.